Hello everyone. I'm Gary Machado at EENA, by the way. A warm welcome to today's EENA webinar on native real-time text, also known as RTT, and the lessons learned from the first end-to-end native RTT to PSAP deployment in the world. Only that. Before I go further, let me remind you that this webinar is automatically captioned in your language. To activate the caption, please follow the instructions that at some point might be put on the screen by Amy. If not, that's okay. You can also use the show captions below, and it will lead you to indicate your to choose your input language and output language. Input language for today is English. So back to today's webinar, the topic of real-time text is a growing priority for European PSAPs who have a legal obligation to deploy it at the latest by 2027. However, full end-to-end RTT will require the cooperation of multiple stakeholders. Despite the complexity, native RTT, defined by the FCC as RTT provided by the voice service provider over the VoiceNet network and accessed either automatically on the handset or by activating the RTT option in the handset settings, is possible now and has already been achieved in some US PSAPs. Today, we'll dive into an example of end-to-end RTT to RTT from Texas. We'll unravel the difficulties they faced as well as their achievements within this initiative. We'll discuss the lessons learned in awareness, readiness, technology, testing, and implementation, as well as insights that you can apply to your own RTT plans, improving accessibility for citizens across Europe and beyond. I'm glad to welcome our 4 speakers today. We have Christy Williams, Director of the North Central Texas Emergency Communications District, NCT 911, Tony Dunn, NENA's RTT Work Group Co-Chair, Mike Hooker, Director Systems Architecture Technology at T-Mobile US, and a member of technical staff within the T-Mobile Network Technology Core Network Services Organization. Tony Parrott, VP of Sales in Call Handling Solutions at Comtech. Later on, after their presentation, we'll also hear from James Craig, Accessibility Standards Manager at Apple. Accompanying James is Ian Fish, the manager of the wearables accessibility team at Apple. Dear attendees, please know that you can use the Q&A and chat section of this webinar to ask questions which will be answered after the presentation. So Christian and friends, the floor is yours.
Thank you, Gary. We appreciate it. We are happy to have this opportunity to be here. So today we are going to talk about an RTT to RTT deployment in the United States, specifically in a county in Texas at a rural sheriff's department, which is law enforcement here. So we're going to start by giving some background and history with Tony Dunn.
So good morning, everyone. Yes, my name is Tony Dunn, and I am the co-chair of the Real-Time Text Work Group that was established by NENA. If we can go to the next slide. So we have in the United States a long history of providing equal access to people with disabilities. Starting before 1990, the United States Emergency Communications Centers, large centers, were already providing TTY access, which is the teletypewriter used by the deaf and hard of hearing community. But in 1990, we had groundbreaking legislation that provided equal access for all types of disabilities. And from there, we went into many other types of regulations provided by the Federal Communications Commission. Starting in 1997, we were providing access to people who are using TTYs over wireless phones, wireless handsets. And as technology advanced, we then looked at making sure that we are able to provide 911 access to people who are using their devices, SMS devices. And then in 2016, the FCC adopted rules for real-time text. And so as a result, NENA did establish a committee to address this new technology. And we have written a white paper. So let's take it to the next slide. So the white paper is called, it's an informational document. It's not a standard. And the number 042.1 was approved in 2021. And this document is comprehensive in that it covers all aspects of what's needed in our systems to provide end-to-end real-time text. So the next slide, please. This slide gives a quick overview of the differences between TTY, SMS, and real-time text. The document goes into a lot more detail. It has actually 5 components to it. It has information about devices and then over-the-top applications. It includes wireless service, provider IP, next-gen core services, and also PSAP IP networks, as well as the functionality needed in call handling equipment. Next slide. Also in this document, we identify the areas of who's responsible for what in all of these 5 areas. And so this just gives you a quick look. And this document, I want to say, is available on the National Emergency Number Association website. And we have that information in the slide deck. And I assume that these slide decks are going to be shared. But this document right here is available to anybody who wants to take a look at it and see what's applicable to you in Europe. Next slide, please. So in the United States, we do have steps to be able to actually receive RTT. PSAPs have to, obviously, Christy's going to go into this in a greater detail, but PSAPs have to have the functionality to receive native real-time text in their equipment. And then once they have that, they can outreach to the carriers. And the carriers have been provided information from the FCC, the Federal Communications Commission, that they must meet that request to provide real-time text through their networks within 6 months of the request from the Emergency Communications Center. So that's kind of our process here in the US, but as I said, the rest of the panelists are going to give you quite a bit more detail on their processes. Next slide.
And I'm Christy Williams again. I'm the director for an agency that covers over 40 PSAPs in the Dallas-Fort Worth area in Texas. And if we can have the next slide, our territory, we're very fortunate in that we have a technology team in-house. And this is not common in the United States, but this is something that, because we're so large, we were able to build a team several years ago. And so they started working on different pilots with Tony and the NENA Work Group. We went through a couple different pilots with different vendors, testing the waters of RTT. But eventually, when we decided to implement, we sent requests to all of our carriers in the US, the 3 major carriers. And of those carriers, T-Mobile was the first to respond and the most eager to move forward. And so we partnered with them. And SolaCom, which is part of Comtech, is our call handling provider. So we partnered with them and worked through an implementation process, a development process, and extensive testing. And so it was a long journey, but finally in August of 22, we were able to implement the RTT to RTT. And we call it native IT or RTT because in the US, the mandate on the carriers to have RTT for the general public was passed, but 911 systems in the United States didn't have the capability to operate that effectively through 911. And so today, if anyone calls most PSAPs in the United States, those calls are converted to TTY or TDD, sorry, all those initials. So it's converted, and that is where we get the term native RTT, is that's not a conversion. It's usually using the true RTT technology provided by the wireless network and the wireless providers or carriers. So next slide, please. So why is RTT important? You know, we hear this all the time. You know, there's a small percentage of deaf individuals. Well, you know, that might be important if you are the deaf individual, or if a family or a loved one is. In 911, every person is important, and we serve everyone. However, I will admit that when I first started hearing about RTT, I did not think it concerned me or my PSAPs, because this was an FCC mandate in the United States, which meant that their regulations and rules applied to our carriers, not the PSAPs. So I lived in my this is not my problem world for over a year, until I went to an FCC meeting, and some of the carriers were doing demos on their RTT solution. And suddenly I saw what they described as the conversion. What I saw were just huge red flags, because the conversion really brings into play many limitations and, in my opinion, some potential liability. And I think that in the day, Tony Dunn and I went around the state of Texas, and we were advocating for proper training for TDD, and that there was a lot of it. And then with the passing of the ADA that she referenced, there was even more training, and training done on a regular basis every 6 months. There's a requirement for that training in our PSAPs. But the reality is TDD calls or TTY calls have been getting less and less, because that community is using some different forms of communications. And so our telecommunicators just weren't seeing it as much. And with this RTT to TTY conversion, we weren't able to identify in the PSAP that it was an RTT calls. And in fact, in our testing, we learned a lot of those calls came in as silent calls. And for me, that meant if you can't identify it and it comes in as a silent call, and the telecommunicator doesn't challenge that call like they used to be in the habit of when TTY was more common, then we could actually miss a real 911 call, and that's not acceptable. And then if they did identify it, there were still other limitations. There was the terrible garble. I don't know if any of you have participated in a TTY call through 911, but it really has some technical difficulties with the garble and letters and characters that just come over the screen willy-nilly. And the other thing is our general public was not educated on RTT being converted to TTY. And so when our machines would do the auto statements, and when we would respond to people, it would use the TTY terminology of GA for go ahead and SK for stop keying. And the general public wouldn't have known what that meant, and would quite possibly have been very confused. So we just felt like that was a lot of limitations, and we needed to fix that. So indeed, this is my problem, and we needed to work on the implementation of RTT to RTT. But that requires a lot of planning and having some money to do some of these things. But most of all, intense coordination and collaboration. And we work with our vendors all the time, and we often refer to our vendors as partners. But I can tell you, I've never seen the partnership than I have over the last 5 years working on this project, and particularly with Comtech and T-Mobile. We have had a great partnership, and they have really worked on the development of this and the testing so that we could be successful. And I'm so thankful for that. We knew it was important to push the vendors in the market to offer RTT to RTT and 911, because I think a lot of people in the 911 business probably thought, like me, this isn't our problem. So it was important to me not only to implement the service, but to raise awareness with the 911 community. And so Tony Dunn and I, for years, went around and did presentations at different conferences, really encouraging 911 centers to work with their vendors and get this RTT implemented. And we did start working with the different providers, and we have had good experiences and conversations with many vendors, not just these two, but these two stepped up to the plate and really hit a home run for us in the implementation. Next slide, please. So what we saw when we went into the, as soon as we heard about these limitations, the first thing we did was we ran to a couple PSAPs and did extensive testing. And what we learned is not only were there all of these limitations, but there were also a lot of differences in the test calls that came in. For instance, each of the wireless carriers displayed the calls differently. T-Mobile calls came in as a wireless call, and Verizon calls came in as a wireless call, but they would send some auto characters that would help trigger the auto detection if we had that in place with our call handling. And then AT&T RTT calls came in as nomadic VoIP calls. So those were some differences. We're used to a class of service that identifies what kind of call it was, and there was not one, is not one for RTT. And so we were seeing all different classes of services as these calls came in from the different providers. And beyond that, it also depended on the type of phone, the actual device and operating system that they use. So Apple phones would present themselves with some different challenges than we would see with the Android phones, which also had challenges, but different in that conversion world. So working with all of the variation made training very important with our PSAPs, training and awareness of this problem. Next slide, please. So why do we want RTT? Well, I've already told you we want to get rid of those limitations with the conversion, but there's also some advantages to RTT above and beyond our text to 911 solutions that we have in the United States using SMS. One of the biggest ones, one of the limitations of SMS that we've had and our telecommunicators have been concerned about for years is that they can't hear the background noise, that it's just a data transfer. But with RTT, for the first time, we have the ability to have both a voice and a data path simultaneously. So now we can do the texting back and forth through the data path, but also have the voice path open so that the dispatchers and telecommunicators can hear that background noise. And I think that's really exciting. Another thing is that, I mentioned that TDD and TTY calls were declining, and part of that is a lot of people don't even buy those devices anymore because of the different communications methods available. And so this is a communication technique that does not require purchasing different devices. So it saves our citizens money. Another big benefit is the ability for both parties to simultaneously send the text instead of the TTY, where you have to stop keying and then let the other person know it's your turn, and then they begin keying. Here, you don't have to wait for, if the dispatcher's asking multiple questions, the caller wouldn't have to wait until they were finished. They could go ahead and get some text sent back so that there was an awareness, and being able to interrupt or say what they need to say as quickly as possible in case they can't continue to text later is another big advantage of RTT. Another one is the utilization of the full international character set. And so for the first time, we did not have this with TDD or TTY, and we also did not have this with our SMS text solution, but here we would be able to use symbols and emojis and different language characters. And the emojis, I know we all laugh at and have fun with, but we also know that there are some learning disabilities and cognitive disabilities that are actually people with those disabilities are communicating using emojis. So that can be very important during an emergency as well. So in all, we just really reduce a lot of risk and limitations that we see with the current TTY conversion in our industry. Next, please. So the way we started, as I mentioned, is we went out and tested in the PSAPs. On the screen, you see some of the different things that we tested. You know, it wasn't just all those limitations, but we were curious about location information and can we transfer the calls? And if we do transfer the calls, how does that transfer? And what are the expectations of our telecommunicators and of the public and of any potential callers? Because as soon as our FCC passed their rule, the carriers implemented the service, and any citizen, not just a deaf citizen, any citizen could activate an RTT call to 911. And so we felt like it was just really important to make our industry aware. And in my region, we had a responsibility to educate and train our PSAPs on the current situation and the limitations they had and the benefits of RTT, so that they would all want to opt in to implementing RTT to RTT. And that took a little bit of time, but we have developed training materials and we're happy to share those as well. Next slide, please. So before requesting RTT, and this is part of the checklist that Tony went through, we have to have next generation 911. You have to work with your call handling provider as well as your next generation core services provider. And in our case, both our call handling, which was SolaCom, and our network, which was Comtech, are the same parent company. And so we were able to come up with a solution using the call handling equipment as the primary part of the RTT solution. Next. So we did have, timing wise, we had a procurement out, a request for proposal. And as we put that out, we gave our vendors 6 months to comply with everything. We made sure that they understood the mechanics of RTT and that we needed a voice and data path, that we wanted character to character messaging, which is that simultaneous text that I described earlier. We wanted to make sure that there was an indication that this was an RTT call, some kind of identification. We wanted an automated initial message, which is that, you know, just like we have with TTY or even text, where as soon as the call is initiated, a response goes out that says 911, where is your emergency? And so we wanted that, as well as the canned messages, to be available. Our telecommunicators don't have to use those, but it allows them to have some questions that are used often already answered with some canned messages that would save time in their typing. and logging of deleted messages. You know, one of the things we learned with text is that if we have, let's say, a domestic issue going on, that there may be someone that is texting for help, and then the assailant comes in, takes the phone from them and says, oh no, sorry, this was just my kid playing, ha ha ha, everything's fine here. And we wouldn't know any different. And so with RTT, we're able to see when things are deleted, and we wanted to make sure, because it is simultaneous and character by character, but we wanted to make sure that our recording of these messages included the deleted text in case it had to be taken, the call had to be taken to court. And I think one of the greatest things that SolaCom did for us during this process was they were developing the character by character, and they did it for the caller, but for the telecommunicator, they left it store and forward, where you would write out your whole message and then hit return, and it would go to the caller. And there was just a difference in perception of what people would want. And so when I said, you know, for RTT to RTT, we really want the character to character on both sides, they did the most wonderful thing, and they give us the ability to choose. And so we can do it either way from the side of the telecommunicator. So it was important for us to get those requirements into the request for proposal and into our contract. And that allowed us to work on development of this technology with our partner of SolaCom. Next, please. And in the United States, we have to send letters to our wireless providers, and we did that. And then you work with those wireless providers to implement over a 6-month period of time. And that's what we have done with T-Mobile. And they have also been an amazing partner, and it required a lot of testing, and we really appreciate the work that we've done with T-Mobile. Next. Overall, the lessons learned is, for us, it was a very slow process. We started the process in 2017. And if you go to the checklist and the document that Tony provided, and I think there was a link on the page for this webinar, then you'll see all of the items that were required to even start, and all that testing, because it was just a world that was unknown. Now we know more as industry, and now at least we know that T-Mobile and Comtech have technical solutions, and so it will be much faster for other PSAPs in the United States to do this type of implementation, because it has been done. And for us, there was some cost involved. And again, once the providers implement this technology, those costs will be reduced or eliminated for other PSAPs as well. But we did have to work with our vendors and get that technology developed. And for us, we needed a point of interconnection. So that, again, took time to order the circuits, and it took some money to take care of that. So that is a nutshell of the implementation in Hood County. So we'll move on to the next slide. And the next person. Tony, I'm going to hand it to you.
Okay, thanks, Christy. And again, thanks to EENA and the opportunity to speak with everybody on the webinar today. My name is Tony Parrott, and with Comtech SolaCom, and I'll just speak to the call handling side of everything that Tony and Christy have talked about so far. So this really is a new interface for our call handling equipment, which is called Guardian, to interact with. So we've been taking SIP calls, IP calls from 911 for a number of years now, but a little bit different kind of interface. So we had to develop that interface to the standard, and that was done. As Christy said, there was an RFP, and it was a requirement for us to do that with some notice from NCT 911. So we were able to accomplish that. A lot of things in consideration of that, and it's another interface, is the security side and making sure that the connectivity and everything met security standards, and then the call flow within the PSAP. You know, we've really introduced to 911 centers in the US, a lot of new things. You know, if you go back even to wireless 911, there's so many different varieties of 911 call today, and this was a non-voice or voice. That's the one thing that makes it different with RTT. It can be voice and text simultaneously. So a different type of call flow, and how does that look to the operator of the equipment? So that had to be considered as well. Storing the data, MIS, Management Information System, being able to keep long-term records of that as well as short-term records of it and call history. So there was some initial design that was done, and another real benefit in Christie's organization, they actually have a dedicated lab system. So we're able to work with the staff there in a controlled lab environment, to fine tune things as things went through the process. And it was mentioned, we saw some differences between different OSs from the network side. So that's really more of just an awareness thing for call takers to be aware of as they're using the technology. And I'm sure some of that is going to refine itself more and become more functional, very functional now as time goes on. So those were the main things that we had to consider. And so just thinking about it on the administration side, this is a screenshot of an admin's menus within our system. And you know, the immediate sending was one of those things that we initially didn't have in the design. We wanted to let the call taker type and then hit send, which does require a little extra thought on their part to actually hit the send button like they would on a TTY call. So that was added as an option to be able to send immediately and see those characters as they are typed both by the call taker and by the caller into 911. And there were some other refinements that were made along that line, but it's an option now for the call taker to determine how they want to operate. So when a call comes in, an RTT call, we thought it was important that it be identified very clearly. So in this screen, you can see RTT, and it's kind of an animation on the call taking screen. It flashes RTT because these aren't calls that are going to be the most common call received. And so it's really important to give as much notice and heads up as this is an RTT call for awareness. So that comes in as RTT. And then I'll just draw your attention to a couple other things on the screen. As was said, this is native RTT, so it's not a hybrid. It's not converting. It's native RTT. And so when we display that, we have a multimedia window there on the right-hand side where we'll indicate via this icon that it's an RTT call, because there are other types of media that could come into the system. So we're trying to just clearly indicate this is an RTT call. And then we're also able to show in the connections window who are the parties on the call. So you can see the call taker is the first party there, and then the RTT caller indicated by a little RTT balloon right here on the screen. So many different ways, just trying to indicate that it's an RTT call, and there's no doubt about the type of call. So this is an example. If you can see the characters are being typed out, and if you notice that carefully, you can see that the characters were changed. So the caller could be typing, and then they can backspace out, and then they could change what they said, much like listening to a live call and hearing background noise, you know, things that are happening that aren't the initial thing that the call taker's concentrating on. So this was another important thing, to be able to see those characters, the backspace deleted characters. So that would be done through a local call history menu for short-term retrieval. And I'll blow this up a little bit here. You can see the date, the time, the phone number, and if a character is backspaced through or deleted, it puts these brackets through it. And then what was actually typed out after that, my husband shot himself. So this is short-term storage for a call taker, supervisor to go back and look at it any time. And then we also make that available for the MIS provider, whoever that might be, so it can be stored long-term. The call history, because we're now dealing with different types of calls, you can see here, this is a voice RTT call with a little red indicator there. And then once the call taker goes back and looks at a call, if they want to look at a previous call, or supervisor walks over, they want to look at the call, they can come down and select a button that will allow that conversation to be displayed back on the screen. So here you can see the initial message, or the welcome message, as it's sometimes called. You've reached 911. What's the location of the emergency? And then you see what was typed and then backspace through, as well as what was typed after that. So that's available for retrieval after the call by the call taker or by an authorized supervisor. And so that's just a quick review of the screen and how it looks and how RTT we're trying to incorporate into the call flow to make it as easy to process these and as efficient as possible. So with that, I'm going to turn it over to Mike.
Thanks, Tony. Mike Hooker from T-Mobile. I'm a network architect, and I look after our NG911 strategy, which includes the delivery of native RTT. So thanks for having me here today. I'm going to talk a little bit more about the overall landscape from the carrier perspective. A lot of this has already been said, but it's, I think, worth going over again. RTT to TTY conversion with gateways has its drawbacks, and those are kind of laid out there on the left side. It's slow, it's half duplex, which means that only one type of media can really work at one time, voice or text. RTT is not does not like non-IP technologies. That's what can lead to the garble that was referenced before. Of course, the need for turn-by-turn TTY etiquette is something that everybody's not always prepared to negotiate. The limited character set, which means it's less open to all of our community. And really the benefits of getting the native RTT established that we're delivering on all of our mobile devices today is it's fast, it's 5G fast. Again, it's the simultaneous, it's 2 media streams, so you can actively have voice and high fidelity going on at the same time as exchanging chat messages. I saw some questions in the chat about it being multilingual, and there's the support for special characters goes a long way in improving accessibility in that way. I think down the road with next gen RTT combined with things like conveyance of language preference would be very powerful to make sure that you can connect certain types of texters or callers to the most appropriate call taker. And so really the bottom line for our perspective, this is a win-win situation. It benefits both public safety, but it also benefits our community and from the T-Mobile perspective, our customers who we try to take care of when it matters most. Okay, so next slide. This is kind of taking a big kind of a step back at a high level architecture is kind of laid out here. In order to have this, full duplex simultaneous mode requires all these components to be in place. And again, the work with NENA, the informational document that covers all these in greater detail is a great resource. But essentially, it requires everything from the origination side, which is the smartphones that we sell, all the smartphones in the stores that T-Mobile sells in the US. They have this capability, and they have for quite some time. So essentially, everything on the network supports the capability. Now, another thing in the US, we've been very advanced with VoLTE, and now even voice over 5G is now available. And you need that capability in order to support the RTT call delivery. You have to have moved off of legacy circuit switch technologies in order to make this possible. A big part of our NG911 strategy has been to recognize that the need for seamless IP connectivity. So as a carrier, for our part, that means coming up with the right strategy and the right partners to establish seamless IP connectivity to the available NG911 networks that are out there in the US. We happen to use an aggregator for that. So our VoLTE calls, including 911 to RTT, go through an aggregation point that is able to also connect over IP using SIP to every NG911 network out there who's ready to support that method of transport. So that's very key. And then past the NG911 IP networks, of course, there needs to be seamless IP from their perspective into supporting NG911 PSAPs, as well as having any gateways that are needed for other legacy PSAPs to support things like call transfers and things like that to legacy PSAPs. If any of these components are not in place, the benefits of RTT are not realized, and the call will fall back to TTY. Okay, so next slide, please. So I talked a little bit about establishing seamless IP as a fundamental requirement to deliver not just RTT, but a lot of the future advancements that will come with NG911 or even NG112 and other deployments. We do, again, I think it was referenced that NCTCOG has their lab, and that's been extremely critical in being able to advance this technology as well as other advancements that are coming. So we run extensive interoperability programs at a partner level. There's never a commercial agreement. This is companies coming together to prepare for advancing these technologies. And from the T-Mobile side, we've established IP connectivity using SIP to every NG911 network out there in the US that's capable of receiving that data. And this is actually a snapshot from a while back. We're close to about 2,000 PSAPs covered where we're delivering calls over IP in the US at this point. And I think that the number of states has grown to about 32. And we have ambitious plans going into 2024. We're actively watching where NG911 programs are becoming available to receive IP. And fundamentally what this means is from us, because we have RTT on our network, is that once the PSAPs do their upgrades that you heard about and the seamless IP connectivity is established, all these PSAPs are going to be RTT capable, right, to be enabled. And so that's really important for us. Since deploying Hood County, we're now you're happy to say we're now active in 4 other states, all to I believe 4 different unique NG911 implementations. And I'm really optimistic about what 2024 has for more the widespread availability of end-to-end native RTT. You can see a little bit of our roadmap as far as establishing SIP connectivity there on the left, where we've recently completed what we have in progress, and some obviously big deployments coming next year with New York City there at the end, as well as some other. All these are critical deployments. I guess one thing, since this is an EENA conference, I would say another benefit to think about with RTT is it's on the same, since it's a voice equivalent, right? So it's on the same path. So when you look at this from a next gen perspective, it's on the same path as other media. So you're delivering text over that same path, which means, location information is delivered the same way. There's priority, and I think that's a big benefit, as well as some roaming scenarios. So as internationally as networks support like VoLTE technology and eventually voice over 5G, when that becomes more ubiquitous, that means that we were able to deliver RTT calls to, say, Europe or to Canada, who also has an RTT mandate when our customers are traveling outside their home country, as well as devices from other countries when they visit the US will be able to deliver RTT over our network that roam on T-Mobile to PSAPs in the US. So I think that's another great benefit, that it's on the same path is 911 voice, or emergency voice, I should say, whether it's 112 or 911. All right, and the next slide. I'm going to hand this back to Christy, and I just want to thank Christy again and Tony for the great partnership in getting the word out on RTT. It's been great to be a part of this team and talk about the benefits and help others as they go down this road. Thank you.
Thanks, Mike. I hope that you've all seen the partnership that we've established. It's been a great journey with our partners, and we certainly appreciate the collaboration that's gone forward and the ability to make it easier for those that follow us. As a summary, we focused on education, training, and awareness in the early days. We started with a readiness checklist that NENA had developed for us in their white paper. We began working with our vendors and carriers and joined them in partnership and began testing in a lab environment, extensive testing in the lab environment and in live PSAPs. And then we also work to develop SOPs, public education strategy, and call taker training. And we're happy to answer questions now, in the future, through email. And we're also happy to share anything that we can to make it easier for you and your journey to implement RTT to 911 prior to 27. Thank you for having us here today, and I'll turn it back to Gary.
Thank you. Thank you so much, Christy, Tony, Mike. It was a fantastic presentation. I'm sure incredibly useful to our members over here. I see that there are already many questions in the chat and in the Q&A section. Please don't hesitate to ask more questions. I want to just maybe take the opportunity to say I'm sorry, we might be a little late, go over the time, which usually isn't the case at EENA webinars, but today I see so much interest that we might have to go over the time. I'm hoping some of our speakers can stay a little longer. First, I apologize because it's already so early for you and we're keeping you away from coffee, I'm guessing, as well. But before we move to the questions, so please again, EENA attendees, please do ask questions, preferably using the Q&A section. But before we move there, thanks again to our speakers. We will now hand over to James Craig, Accessibility Standards Manager at Apple, with 2 decades of experience in user-centered design, engineering, and accessibility. He represents Apple's accessibility interest in various standards organizations, including the W3C, ETSI, and the FCC's Disability Advisory Committee. Accompanying James is Ian Fish, the manager of wearables accessibility team at Apple, who will be here to respond to questions as well. He represented Apple during the creation of the RTT specifications and was responsible for RTT development at Apple. So James, the floor is yours.
Yes, thank you for inviting us. Happy to be here, and thanks to all the prior speakers. I learned a bit about some of the deployment, so thank you for that. So I was asked to talk a little bit about Apple's development of RTT. We first shipped RTT support in 2016 with the iOS 10 release. This was not initially available to customers directly because there weren't any carriers that supported it, but the carriers were able to support it then by sideloading a carrier bundle, so they could initially start their testing. So that's been available for all carriers to test since 2016. At the time, we worked with the large US carriers as well, the big 4 at the time, which are now the big 3. And Android, Google shipped RTT support soon after iOS. I don't remember the exact time, but I think it was probably 2017 or 2018, give or take a year. After the release of iOS 10 in 2016, the carriers started testing and kind of rolled it out into the 2017 timeline. So all 4 major US carriers, AT&T, Verizon, T-Mobile, and Sprint. T-Mobile and Sprint have since merged, but all of them supported that by around 2017, 2018. Initially, that was only supported as RTT calls on the same network. So an AT&T call to another AT&T customer, or a T-Mobile call to a T-Mobile customer. That reduced some of the complexity, so they were able to ship that first, and then started working on inter-carrier deployments. So I think AT&T to Verizon and Verizon to AT&T was the first. The primary delay for that portion of it was the US's requirement to fall back to the TTY analog standard. There was a lot of talk about TTY before, but just to make sure that everybody's on the same page, in Europe, this is sometimes referred to as teletype or text telephony. It's the analog standard where that uses the audio channel to send. I believe it may be limited to ASCII characters, so it doesn't support multiple languages, and it's very lossy over the audio, etc. It's not the digital standard. So RTT became widely available in the US by 2018, at least between the major carriers. So the big three, T-Mobile, AT&T, Verizon, all support that. All supported that by 2018. Many other regional carriers followed in the years since. That said, there are still some small carriers that might only support TTY. So small regional carriers, island carriers, for example. I've heard some anecdotal evidence that some of these still only support TTY. So there is this legacy fallback step that still happens. I believe that the EU doesn't have a requirement for TTY fallback, so that should ease some of the RTT deployment in the EU. One of the complications with that was that carriers to carriers needed to know the full endpointing of where the call was going to go to in order to send RTT over the backbone networks. And so if they didn't know where it was going to end, they would all fall back to TTY. In order to make sure that they had that they didn't drop something along the way, they would need to have contracts between every carrier, so every carrier to every carrier. So that drastically increased the complexity and slowed the rollout of digital RTT in the US because there was this analog fallback requirement. Given that I've heard 1,000 carriers. I don't know how many of those are MVNOs, but I've heard there are 1,000 carriers in the US, or maybe more, compared to the 100 or so in the US. I would say you should be thankful that that isn't a requirement. So the US call center rollout, Apple worked with a number of PSAPs in the US to test RTT to 911 deployment. Here in Cupertino, we partnered with the Santa Clara Sheriff's Office, but there were more in other jurisdictions. Right now, it's possible some one of the other panelists could speak to this, but we only have anecdotal evidence about how widely PSAP deployments extends in the US. So it's not quite as rolled out as the kind of consumer to consumer RTT. I've got more information on the technical standards. The one thing that I will mention is, because it came up in the comments, right now it's widely deployed in the US as two-party RTT. So that uses RFC 4103 in the protocol. And ADIS has a document 0700029, which defined the user expectations for that two-party RTT. The question that came up in the comments was about multi-party RTT. How does it support that? So multi-party RTT is emerging. The plan is to support RFC 9071 for multi-party RTT or RTP. That was actually written by Gunnar Hellstrom, who's on the call. He and I and others worked directly with ETSI on TR 103708, which is the updated user expectations document for multi-party RTT. Agata Sawika is still on the call, and she's chairing a group at ETSI TCHF that is doing ongoing work in that particular area. So there are a number of people on the call that are, Robert Hecht as well, a number of people on the call that are actively involved in the rollout for that type of thing. So in summary, RTT in the US has been widely deployed and supported for well over 5 years. It's standard, it's built into iOS and Android natively. This is part of what was referred to as native RTT deployment. It's supported by many carriers, including all major carriers in the US. It's supported by multiple PSAPs, though unknown exactly how many. Apple's worked with industry advocacy groups and standard bodies at every step of the deployment and the rollout. RTT is ready for deployment in the EU. It's been ready for years in both iOS and Android. It's supported by the equipment providers. You saw Tony's demo earlier today. There are other vendors as well that support this. Supported by backbone network equipment. I'm aware of Cisco. There are other vendors as well. EU carriers can sideload a carrier bundle at any time to start testing it on their networks. And once the carriers support RTT, then the call centers can start testing it out too. So I'm looking forward to that, and we are looking forward to helping ease that transition in the EU. And I think it's ready to go, and happy to answer any questions. Thank you all for having me.
So much, James. Was extremely clear and extremely welcome. Thank you. I'm sure the message was clear to our audience. Thank you very, very much. I want to apologize for the delay of today. That we might have to stay. If you all can, dear speakers, if you can stay a little bit longer, that would be really appreciated. Again, apologies for the delay. We will jump right now to the questions. We have questions in the chat and question in the Q&A section, and many of them. So let's take them one by one. What was the total time needed from start of the project to the actual completion of the project?
Well, I can tell you for our project, it was approximately 5 years, but that wasn't the time we spent testing with T-Mobile and SolaCom. That was the beginning to end. Once we identified the problem, started our awareness, our training, our research working, we had to work through that RFP, so we had requirements in place. I believe that implementations are going to go much quicker from here on out.
Thank you, Christine. Thank you very much. Next question. What is, since implementation, the proportion of RTT usage in relation to all emergency calls? And has the introduction of RTT, in your experience, potentially had an impact on the number of emergency calls in total?
In our area, I can say that the calls are very, very low, just like our text to 911 calls are very low. I believe that we're very cautious about public education until our whole media area has a service, because we don't want to confuse our citizens. And unfortunately, in a small area in Texas, we have multiple 911 entities with different levels of service. So it's a little more complicated for us, and we haven't done a lot of the mass notifications yet. So I anticipate things will pick up a bit, but we've had text to 911 for 10 years, and it's still less than 1% of our call volume. So I don't know that it will become a huge percentage, but as I mentioned before, if we're able to save one life, it's worth all the trouble that we put into it.
Thank you. Very clear. In the Netherlands, end users can use the 112 Netherlands 112 NL app to contact emergency services with RTT, but that still requires a third-party app. What does native RTT look like on the end user smartphone? What does it require to work for the end user? Maybe that's more a question to Craig.
Yeah, this is James. I can answer that. So fine, I answered both names. In iOS, the user interface for the text interface is built into the phone app. So right there, along with the mute button and the keypad button, you'll see that it comes in as an RTT call. user can actually define preferences to say, make all outgoing RTT calls, automatically receive any incoming calls as RTT. And if you receive a call that is initiated on the other side as RTT, then even without that preference, you'll start it as an RTT call. So that can be audio as well as text. And there's a texting interface that is similar to a messaging type app. You see the turn taking, but during live text, you will actually see the characters coming in real time. So it's built in and native and just part of the phone app effectively. If you leave the phone app during a call and you receive a message, you'll also get a notification in view that the text log has been updated, and you can usually review that call log after the fact as well.
Thank you, James. Very clear. Next question is RCS used to sync the voice and the text? I think you can take this one.
Did I hear the question correctly? Is RCS used to sync the voice and the text?
Yes.
Is that the question? Yeah. So there's no dependency on RTT to support the technology, and the way that the system works, the end-to-end system for emergency calling works with end-to-end IP connectivity, is that you're able to set up 2 independent media streams. So those are 2 both simultaneously up at the same time.
You might. A question from Stuart: is automatic location handled as part of this process, or does it rely on AML? Not sure a mobile call is involved. AML stands for Advanced Mobile Location here in Europe.
Yes. So so AML is obviously a common way to deploy location conveyance in certain countries. In the US, it's a little bit different, especially for it's different in the US. We have mandates that are very strict for meeting certain accuracy requirements, and the way we're meeting those requirements, like 80% of calls with estimated error of under 50 meters, or accuracy under 50 meters, and a vertical plus or minus 3 meters, is we are also using device-based technology from the OS providers, and we deliver that location through our network to E911 systems or NG911 systems, just like we do for voice. And there's not a need typically to have AML, whether it's SMS, directly to public safety. A lot of the carriers have deployed some over-the-top mechanisms. T-Mobile, for example, has ELS implemented. We're the first to implement that technology, that method of delivery using AML HTTPS to our network. A lot of that was to get backwards compatibility to devices that weren't able to provide device-based hybrid technology natively. And so that's no longer the case on newer devices, but for a time that was another way to source accurate device location.
Thanks, Mike. Very clear again. I'll jump a few questions because some other questions are also on location. I will go to Mick Fox. Question to the folks at Apple. Can you clarify the process for side loading a carrier bundle, please?
Sure. This is handled between the carrier and the carrier account manager. So the carrier can request a TTY RTT test bundle directly from their account manager. And the specifics of which would be handled by that account manager. I don't actually know the details.
All right, and I'm sure also many of you attendees in the call have a regular Apple contact in Europe. I'm sure that person would love to help you in case you have further question on that process. Thank you very much, James. Another question is for roaming users. How is the call assisted in terms of user language? If the user language is other than the roaming user connected PSAP? I mean, any of you able to answer on roaming issues, or as you may guess here over here, roaming and languages issues pretty big.
Yeah, I think that's I think that's a great question and highlights a future advancement that I think that we should all be working on. There's ways to convey language preference over the top that have started to become available. But next generation 911 offers a standard way to convey things like language preference. So as we get all these stakeholders together that have deployed RTT, and we can come together to also send language preference, not just with RTT calls, but any call, I think that's a very worthwhile effort to take. For us, it's part of NG 911 implementation, and just like RTT, as it becomes supported by adjacent networks and public safety in other countries, then these two can go hand in hand.
Thank you, Mike. I'm moving to the chat and reading questions from the chat now. Question from Björn from Sweden. Are there any issues around roaming, both between mobile network operators and concerning foreign mobile phones using real-time text?
I could answer this question as regards to emergency, and I'll just say that overall, for all types of communication methods, the primary requirement that needs to be met is that the networks that have roaming agreements need to be on VoLTE technology in order to support things like RTT. So where things get a little challenging is when one network supports VoLTE in the US. I think everybody's aware of our movement to go to VoLTE. If there's another roaming partner who has not yet upgraded the devices or their network to support the technology as well, there can be limitations into advancing things like RTT communications natively end-to-end.
Yeah. Thanks, Mike. Another question is, can you comment on the adoption among the general public so far, since both Apple and Android phone manufacturers see this as an accessibility feature as opposed to a mainstream feature, since RTT need to be enabled under accessibility settings in the phone? Will the percentage of call always be low, say 1% of total calls or below? So mostly the question is around the adoption among the general public of RTT usage, which I think we actually previously answered. It's below probably the 1%, not expected to go above 1%. Maybe Tony, Dan, you want to say something? Yes.
Yes.
I
just would like.
Go ahead.
Sorry.
Go ahead, Tony.
I just would like to add that the community is also learning about RTT, and I think the more that they become aware of this technology, that they may, there may be an increase. But even if they do use it more, we still have a very low percent from the deaf and hard of hearing community. But as the general population becomes more aware of it, I'm not sure, because this has never been an option that the general population has used, except for SMS text. So, well, I think that it's something we're going to have to vet to see.
Very good.
And this is James. Just to add on to that, I'm not sure if the question was about how many people change their preferences or how many calls are going through, but I just wanted to reemphasize the fact that at least in the native implementations, you don't have to have that preference set in order to receive a call in RTT. So if the call comes in as RTT, or if it's upgraded to RTT midstream in the call, you'll see that interface regardless of what your local device's preferences were.
Thank you. There's another question by Björn about, is RTT service a single language service? Do you offer chat only in English? How do you manage translation? And so on. Maybe this is a complicated question. I can give my own view on that. Just to say, Björn, that there are some even European vendors that already provide text, AI-based text translation also for RTT. So as you type, you can see the AI-based translation in several languages available. Just my own comment on this. Anyone else wants to add to this text?
Just to mention that it obviously supports Unicode, so the ability for end consumers to use it in any language is there, in any keyboard entry or any text entry service that they use. As far as the services, the PSAP services that translate, that would be a separate support contract, I believe.
Good. A simple yet complicated question. What does native solution? What does native RTT mean? Do any of you want to take it, or do you want me to read the FCC definition?
Just very simply, it's when a call originates as RTT with that technology and it's received with the same technology. So when we're talking about it in our document, it's from origination to receipt. So it's the complete path is we call it native RTT. So that's kind of my simple explanation, but there's a more detailed explanation, I'm sure.
I mean, I think I can tell you from my perspective, it's about, who's using the technology on either end. Are they using the tools they normally use for, like, say, voice communications, or they do it the same way? Do they, if you're a 911 telecommunicator, are you required to have another screen in order to make this function that's, on a different terminal somewhere? Or is it integrated into your call handling software? And that's what Tony would reference. And from the device perspective, it's also the same way. I'm going to make an emergency call and I'm dialing 112. Am I able to start that RTT from that same native dialer?
Yeah, and I think the critical piece there is it's digital and supported all the way through that chain, right? On the device and the carrier and the call center. And usually native RTT refers to not a standalone third-party app as well. So from the caller, there's lossless, text transmission in Unicode versus sometimes between the backbone providers, if they've downgraded to TTY and then upgraded back to RTT along the way, there might be lossiness, so that wouldn't count as native RTT.
Very clear again, thank you. And this is the last question. I'm sorry, we won't be taking more. The last question is from Katya. Can you switch from a normal audio call to an RTT call during the call?
Yes.
The simple answer is yes. That was...
the slightly longer answer is that most of the carriers in the US have supported these as all calls are audio calls. That can also include a side channel for RTT. And so effectively when it's an RTT only call, that is a muted audio call that also has the RTT side channel.
Excellent. Thank you very much. We won't be taking more questions. I want to give a special greeting. There is Gunnar on the call. Him and I used to be in the Region 1-2 project many years ago. He taught me so much about accessibility and got me interested into this. So thank you, Gunnar. So while we move on to the end of this webinar, I really want to thank our speakers because it was very early for some of them. So thank you so much for taking the time so early to share all this with us. It was super interesting, really. And really thank you. So I hope it has inspired, and I think it has inspired our European members attending this call. And I hope also that many of you in this meeting now know that RTT is possible. I think that the message was put very clearly today, that it's possible to get it done even before the legislative deadline for PSAPs in Europe, as per the Delegated Act of the EECC and the European Accessibility Act. Please don't hesitate to contact us or the speakers today if you wish to follow up. If you're interested in this topic, please know that we will have several sessions dedicated to RTT and accessibility at the EENA conference in Valencia, 24 to 26 of April. I know many of the speakers today are trying to make it to Valencia. Let us know if we can help and if we can support in any way. We hope to see you deliver about the same presentation in Valencia. We're very much looking forward to it. I'm also announcing the next webinars. On 17 January, we will have at 2:30 p.m. a discussion on exchange of data in PSAPs. On 29 of January, 2:30 p.m. presentation about Galileo emergency warning satellite service. On 30 January, the European Innovation Council funding opportunities will be presented. And on 15 February, it will be Horizon Europe research opportunities in disaster resilient societies, which will present EU funding opportunities as well. I know there was, by the way, a question about funding, which I couldn't relay today. So good next webinars to attend about funding, how to fund the next steps. You can register to these webinars via our website. A big thank you again to all the speakers today. That was really excellent. And it's time to wish you all a great afternoon, evening, or morning, and see you all very soon. Thank you.
Thank you.
Bye-bye.
Thank you.
Thank you. Bye-bye.